All right, let's look at the second order linear differential equations. All right, so the form of the equation is you have some function of x, ax, times y double prime, plus b of x, y prime, plus c of x, y is equal to right-hand side function. Right, so as you can see that the highest derivative is the second derivative. That's why it's a second order. And this is in a linear form, so you have a function of x times y double prime, a function of x times y prime, and a function of x times y. There is no y squared or y times y prime or anything like that. So it's a nice and linear. All right, so when right-hand side, capital F of x is equal to 0, so if f of x is equal to 0, then the equation is called the homogeneous equation. So I'll just write that down, homogeneous. Right, so whenever somebody say it's a homogeneous equation, which means that the right-hand side is going to be equal to 0. All right, so here's an example of a second-order linear equation, something like x squared y double prime minus y x times y prime minus 6y equals e to the x. All right, so what would be the good application of second-order linear equation? All right, so here's a very good example. It's called the mass spring dashpot system. So basically, you have a mass attached to a spring and also a dashpot, and dashpot is like a shock absorber. All right, then so here's the system, and you can maybe start pulling the weight a little bit and start oscillating. But because of the shock absorber, the oscillation is going to eventually die down. All right, so if you remember some physics, all right, so spring is always the force by the spring is proportional to the displacement, and it's the opposite direction. So we can write the force of the spring. I'm going to call it the F sub s is equal to, right? So since it's the opposite direction, negative, right? And proportional to the displacement, I'm going to call displacement x, right? And proportional, so you have some constant k, right? K is a spring constant, right? And the dashpot, the force from the dashpot, so I'm going to call it the F sub d, I guess, right? Again, the direction of the force is going to be always opposite of the motion, so it's a negative sign, right? And the force is proportional to its velocity. So the faster you try to move it, it's gonna the more force it's gonna exert against it. So it's going to be proportional to velocity v, right? And it's a constant. I'm gonna have to do something else. I'm gonna use constant c for the dashpot constant. All right, so the velocity is simply the derivative of the displacement. So this is can be rewritten as negative c x prime. All right, and another Newton the physics fact, Newton's second law would be force is mass times acceleration. Right, acceleration is the second derivative of the displacement, so it's going to be mx double prime. Right, so the force on the spring, force on the mass is going to be a combination of a spring and a dashpot. So we could write an equation. So we can have F is going to be the sum of the force by the spring, so F sub s, and plus you're going to have F force from the dashpot. All right. Then if you plug everything in, so F can be rewritten as m times x double prime is equal to, right, F sub s is negative k x, and f sub d is negative cx prime, right? And if you consider some outside force, like wind blowing on the mass or something like that, you can probably think of it as outside force. I'm going to just put a little f of x or something like that here, right? Actually, maybe it's f of t, probably, because it depends on time, right? So you would have f of t here. All right, then we put everything except for f of t on the other side. So you're going to have mx double prime plus k. Oh, actually, let's put the c first. Here's a plus cx double prime. First single prime plus kx. Is equal to f of t. All right, and again, so f of t, this is the external force. All right. But you can see that for this the differential equation for mass spring dashpot system, we have a perfectly formatted second order linear equation. And in this case, if there's an external force, this is going to be non-homogeneous because right hand side is not equal to 0. But if there's no external force, which means that it's going to be a homogeneous equation. All right, that's it. I hope that this was clear.